if you are a Gemini CLI user, this is actually really important to do because your context, it plays a significant role in the amount of tokens that you use whenever you're using the CLI tool. Really, any type of AI, context is always going to impact the quantity of tokens you use when you make a prompt call. We don't know what the inner workings of these LLMs are. When you have context, that context is stored in Gemini.md files. You can have files by this name pretty much anywhere within your file system. At the root level, within a subfolder, even within a hidden folder or a get ignored folder. The Gemini CLI is going to read all of these files that have this name, which, by the way, is also configurable. You could configure it to use other file names if you wanted to. But it's going to read all of those files and it's going to concatenate them together to form one big blob. So essentially what this means is there is a additional quantity of tokens that will be a fairly constant amount based on how much of that context you're using, right? And so with every LLM, they always will give some type of number, right? They'll say, oh, this LLM, this Gemini Pro can handle a context window of 2 million tokens. They'll say something like that, right? Well, this is included in whatever amount of tokens you would be using to reach that, okay? And so it's oftentimes the context around your prompts that make them more reliable or that can help to fine-tune them in a direction that aligns with what you're trying to do in your project. So what we're doing in our Gemini CLI session with this project essentially is we're using the context that we write to hold a set of standards and conventions that we would like to enforce while we are operating within the directory. A lot of times as a developer, when you're coding, you're trying to write your code in a way that is clean, or you're trying to write it in a way that is organized, or you're trying to write it in a way that is modular, or you're trying to write your code in a way where you're following certain rules or aesthetic principles about actual code that you want to reinforce. And there may not necessarily be like a whole lot of linting rules or whatever. It could be more abstract things about the organization of your file system even. All of those things we're going to try to describe in enough detail within our context that AI kind of knows not just what we want in any given prompt, but it has more information about how to actually apply that in a consistent way that meets our standards, our code quality standards, okay? There might be other categories, but these are the main categories that I think about when I'm working on my context, which is a specific thing that I make time for as a very specific task. When I talk about avoiding things, what I'm talking about typically is I don't want things like large monolithic files. A lot of times you'll find that AI wants to take a shortcut, probably to optimize token utilization, possibly. But you're going to end up with large monolithic files, and you don't want that. So when you see a file that is anywhere larger than like 500 lines of code, that might be fine. That might be fine sometimes. If that file has a singular concern, if it has a singular responsibility, if it is of a singular theme that holds things, perhaps like a barrel file or something like that, perhaps. But in most cases, when you start seeing files that are like 500 lines or longer, your red lights, your sirens should be going off. when it comes to making edits to files, many of these AI tools have a hard time managing files that are that large. And when your files start to get larger than that, that's when you'll notice that you'll have lots of duplicate functions, you'll have lots of dead code, and it's going to be really, really hard to find those things even because 500 lines is a lot of code. Plus, you probably don't even have comments in there, right? So we want to avoid large monolithic files because they're hard for us to manage, and they're also hard for your AI agent or whatever to manage as well. Encode documentation. So what this means is that almost every programming language has a specific syntax that you can use to annotate what's going on in your code. There are a couple reasons for this. The two that I can think of right now is, one, when someone opens up a file in your source code, you want to have comments that make it apparent what that code does, especially if your code is very difficult to read. Okay, if you have very esoteric code, the comments in your code are going to make that stuff easy for someone to pick it up and to read through it, to know the big picture of what's going on, and then to discern what those parts and pieces do within that bigger algorithm or whatever. Okay, so encode documentation. Also, encode documentation is very important because if you're using your AI chatbot or whatever to handle manipulating files, well, having that commentary inside of them could also provide some valuable insight into context as well. If you have encode documentation, it means that as you export and import things between files, that you get that nice ability to hover over something and be able to read what it does, especially if it's something very abstract or if it's something from a separate library entirely. You know that feeling when you can hover over something that you are using and you can see information about what it does, what it needs, etc. Okay, so encode documentation is something we want to do. Scripts and workflows. This is like, think about this as routines for common tasks. And these scripts can be used in your terminal environment to call your AI chatbot and do the magic for you. But another way you can do this is you can actually just write the series of steps and give some type of call word or keyword and have that just stored in your context as well, right? So just a series of steps. One thing that I think about a lot of times is instructions for how to modify something in a consistent way. Okay, so you can store pre-made prompts and stuff like that, and then just reference them indirectly. And oftentimes for modifications and whatnot, that can be helpful. Oh, we want to avoid using the wrong versions of things. This is like a temporary issue. So whenever you're using LLM, they usually will have a certain date which they were trained. And their model of reality might actually be based on a time period before whatever technology you're using existed, especially if you're talking about a specific version. So here's a really good example. We're going to use Pixie.js for some of our front-end graphic stuff, but Pixie.js has a version 8, but the Gemini LLM was trained presumably before version 8 because it doesn't know anything about it, right? To specifically say something like, when using Pixie.js, please use version 8 and make sure you directly reference the documentation or something like that. We can define an organization strategy. Either give an example of what a folder structure might look like, or I could even take literal rules, right? So if you're like a clean coder type person, you can actually extract things from the text that you like, that you want to enforce, And then you can use your AI chatbot to basically code for you according to those rules, okay? So we want to do cleanish code, and we'll give it some type of description of what that means for us. If you're working too fast, first of all, you're going to miss the opportunities to reorganize your code as you go, to reuse things. It would be a huge task for it to search for every function before it writes to make sure that there isn't something comparable. And then how would it even do that? It would just be a lot. But you do want to make sure that if you're working within a certain domain of your application, it might be a good idea to do a scan or to have it read through some code, or to do something to build that context. But at the very least, you could give it an instruction to do simple things like reuse types. So if you could store types in a central place, you could also have it manage tokens. Like, for example, styling things like CSS or JavaScript style objects, you could have them tokenized and stored in a central place and built from like modular pieces. Like, you're building these pieces and then you're reusing them as opposed to styling in line for each component. So think along those lines, but we want to reduce the amount of duplicate code if possible. This is a matter of reinforcement. You're letting it know, like, this stuff is really important to me. And not only that, but you're going to try to be specific about how this stuff relates to your repos, specifically. Your preferences will develop, grow, and change as you work. So this idea of refining and simplifying context it's a never-ending cycle. Now, as you work on your context, it is going to get larger and larger. Down here, you can see 19 Gemini.md files. If I go and type in /memory, and then I do show, it's going to tell me all the stuff that's in my context all at once. This is everything across all 19 files that's printed out and concatenated together. Okay. So I bet you that within all of these files, there's probably stuff that is useless, duplicated, or even just, unnecessary. When you start to pay for your token usage, or even if you're just thinking about the responsible usage of AI in general, these tokens, they directly relate to compute. So you're paying for it if you don't manage this duplicate information, but you're also killing the planet. I mean, we're killing the planet with AI in general, but that's neither here nor there, okay? You can have an impact by simply being more responsible with managing your context, which is why it's important to do this culling. In my repo, there's probably a lot of files that don't need to be separate. They can be put together. Your token usage is based on some formula related to the quantity of words that you use in your prompts. And so if you think about the amount of words and the amount of letters that are involved in your context as a whole, finding simpler ways to say the same thing, and oftentimes in more direct terms as well, is going to reduce the amount of tokens you use. So we can have different types of context info. Okay, so this can be instructions. This can be things to remember. These can be preferences. This could be info about the project. And this could be workflows. And this could be references to things. So these are all the different types of things that we're going to try to put into our context, but we want to do this in simple ways. And these types of things are going to more or less be our concerns when we're thinking about context. But what makes all this really beautiful is that we can actually use Gemini to help us make the context for Gemini. Isn't that that's kind of crazy sounding, right? But that's exactly how this is going to work. We're going to use Gemini CLI to help us define and manage our context. Okay. Let's first look at how much context are we using. So if we do memory refresh, it says here that we've loaded 45,520 characters from 20 files. Okay. The main thing to take away here is that you can use Gemini to help you manage the context, okay? And if you manage the context, it's going to mean more efficient utilization of your tokens, which means cheaper cost, and it's also going to mean more sustainable. Okay. But you can have influence over the relative impact of your use of AI by managing your context. Once again, if you like this type of stuff, let me know. I'd be more than happy to share these graphics if there is a desire for them.